Hi everyone, this is Mr. Cardoso, and here we are in lesson 6.5, which is comparing and displaying objects. So we're in our objects unit, and this is our next lesson. Alright, so we're here in our fraction class, if you remember from before, and we're just going to go through a couple of examples here in the interactions panel. So remember, again, when I'm in the interactions panel of Dr. Java, this particular IDE, it's considered to be like the secondary programmer. Consider it, for example, that we're in the main method of another class. We're not inside the fraction class when we're doing these lines of code. We're in another class, and we're acting as the sort of secondary programmer. So let's make a couple of fractions just to see some examples. So let's say fraction f1 equals new fraction. Let's say 1, 2. We have a constructor for that now. So we have that fraction, and let's do another fraction called f2, and it has the value 1 over 2 as well. So we've already kind of done this example in another video lesson, an earlier video lesson, but let's just revisit it. So first of all, if I make two integers, int x equals 3 and int y equals 3, and then I say x equals y, what does that give us? Well, the values of x and y are the same, so when we compare them, we're going to get a true, because it's saying x is 3 and y is 3, and it's the same value. That's how it works for primitives, primitive data types, like ints, doubles, cars, what else? All those kinds of booleans, right? These are all primitive data types, and it works like that for primitive data types. However, does it work like that for objects? So f1 equals f2. Now they both have the same numerator and denominator, 1 over 2. So you would think this returns true, right? But as we saw in the previous video, it doesn't. It returns false. So let's go over here to our little notepad. And so we created f1. f1 is pointing to this object 1 and 2. And f2 is pointing to this object. And that also has 1 and 2. So we're saying they have the same values, but are they the same? And why is Java giving us back a false? Well, think about it this way. When we created this fraction object, we're defining it here, with a numerator and a denominator. But Java doesn't know a fraction from a car, for example, like a car, a car that you drive, or any other object that you want to create, a student object or something like that, or a circle, as you've seen in the exercises. So it basically says if it's not the same object, then it's going to return false, right? So these two are pointing at different things. So the only way to get a true out of this is if they're actually pointing at the same object. Now we saw those examples before as well. So for example, I can make a new object, fraction f3. Now this time I won't use the new keyword. So fraction f3 is just kind of created as a pointer. So f3 is kind of just created as a pointer right there. And we say that equals, let's say, f1. So what happens there is, because the new keyword wasn't used, this pointer now comes all over here and points at that same object f1. So that's how that works. And so now if I were to say f1 equals f3, that gives me the value of true. Because what it's saying here is that f1 and f3, these two pointers, are both pointing at the same object, right? And so that's what that's what's a little bit tricky about this. Now that f1 and f3 are pointing at the same object, we have two handles to that object. So we can change the value by using either handle. So for example, f1.num gets 7. Well, if I go to f1 and I look at its num, that means that's now gone, and that's going to change to a 7. Well, that also means, so if I print out f1, I get 7 over 2 now. That also means that f3 changes to 7 over 2 as well, because guess what? F3 is pointing at that same object. So we didn't use the new keyword here. F3 is actually pointing at the same object as F1, the exact same one. And so they're both handles for the same object. Okay, now taking that idea a little bit further, so that basically that's the only way we can get, if we use the equals equals comparator, logical comparison, the only way that we can get it true is if the two handles are pointing at the exact same object. Any other time we'll get a false, even if they have the same values. So that's not very useful. What if we wanted to compare two fraction objects in such a way that we could actually say, well, they have the same values, just like we did here for x and y, these two integers. What if we wanted to compare these two fractions the same way and say, well, they're both 1 over 2, so we want to get a true out of this. Let's say we had an if statement, and we wanted to see if these two fractions had the same values. Then how do we do that? And that's where you have to write in that method. So we'll come in here into our class, and we're basically in our instance method section. We're going to write an instance method to do that. So we're going to go with public, and this is Boolean. Why Boolean? Because it's going to return a true or a false, right? And so we typically call this method the equals method. And usually most objects will have an equals method. And it's the way of you telling the user, this is how we define two fractions being equal. And so for this, we need another fraction. And usually we call that fraction other. We don't need two fractions because we already have the implicit one. So, for example, we can write an if statement in here and say if, this dot num equals other dot num, and this dot den equals other dot den, then we can say, okay, these two are equal. Return true. Else, return false. So basically, only if these two fractions are exactly equal will we return true. Otherwise, we'll return false. And that's how we define it. And we can define it however we want by using the comments up here, right? And communicating that to our user, right? So we want this to be useful to the secondary programmer, the person who's going to call this method. So let's compile that. Oops. And now we're going to go back to the interactions. Let's create those same two fractions, F1 and F2. And now, if I go F1 equals F2, it's still going to give me false. So here, the equals method, it's not like overriding the equals. I mean, that is still available to you. But if you want to call the equals method, you have to call it like any other instance method. So for example, go F1 dot equals F2. And now this will give me true, right? So even though F1 and F2 are not pointing at the same fraction object, as we see here, their values are the same as we define in our equals method. So in this case, for example, F2 gets mapped into other, and F1 gets mapped into the implicit fraction, which is this. So it's checking if this dot num equals other dot num, and so on. Return true, otherwise return false, and so in this case it returns false. So you can throw this into an if statement, into a while loop condition, wherever it is that they take conditions, you can throw that in there, and that's how it can work. Now, you might ask, well, Mr. Cardo, so what about equivalent fractions? So if I make another fraction, let's say fraction F3, and that one is 2 over 4. Now hopefully you recognize that 2 over 4 is the same as 1 over 2 in fraction form. 1 is just in reduced form. But what will happen if I go F1 dot equals F3? We get a false. Even though F1 is 1 over 2 and F3 is 2 over 4, they're equivalent fractions, we get a false. So we probably want to change our definition. Again, that's up to you, and you would put that here in the comments that we're going to check for equivalent fractions as well. So an easy way to do this, because we already have a reduce method, is to go this dot reduce. Right? So we call the reduce method. So we're basically reducing both fractions before we compare them. Other dot reduce. Right? So and remember reduce, it's down here somewhere. We did that in a previous video lesson if you want to go back and check that out. But it's a void method, so it doesn't return anything. Where are we now? So we can just go this is a fraction, it's the implicit one. So we're basically saying if we called it like this, f1 dot equals f3, f1 would be this, so it would be like f1 dot reduce, so that would reduce f1, and other dot reduce, which would be f3 dot reduce, would get reduced, and then we would compare them, and then we would get a true. Now, you definitely want to put that in the comments that you're reducing the methods, because before we call this method, a user might come in here and go, okay, well, my method f3, well, we already did it in the toString. In toString, we reduced it. So by doing that, we've already reduced it. Well, let me reset that. Again, you do want to mention that in the comments, that you are reducing it, because they think they have a fraction like 2 over 4, and then all of a sudden it changes to 1 over 2, and their 2 over 4 is long gone. So you want them to know that you are changing their values of their fraction, which was the point I was trying to make. So let's make that fraction f1 again. And let's make fraction f3 again. Now I won't call the toString method, because by hitting f3 and hitting enter, remember we are kind of calling the toString method, and the toString method will automatically reduce it, because in our toString method we did the reduce. So I'm not going to do that. I'm just going to go f1 dot equals f3, and we do get a false because I haven't compiled this yet. So I have basically these 2 lines of code haven't been put in yet. So now I'm going to compile that with these 2 lines of code in there. Go back in here, do the same thing. And now I'm going to compare, and now I get a true because they got reduced. And so now it checks for equality of the fields. So you can define your equals method, your dot equals method for your object in different ways, right? So if you had a circle object, maybe you would define 2 circles to be the same if they have the same x position or just the same radius. You don't care if they have the same x position and y position. Or maybe you do care if maybe you want them to be the exact same. For example, many of you have taken physics. So what's the definition in physics for 2 vectors to be equal? They don't have to have the same position. They just have to have the same size and the same magnitude. So if you had a vector object that you were doing a class for, then you would define the equals method by checking if they have the same magnitude and the same direction. Right? Did I say size before? Sorry about that. So I meant same magnitude and the same direction. If they have those 2 things in common, then you define them as equal. You wouldn't have to have all the x, y, and z, or I, j, and k values to be the same for a vector. If you're totally confused about this vector example, you probably haven't taken physics or done that section in calculus yet, so just ignore that last example. But my point is, depending on the object, you can define what makes 2 of them to be equal however you want. And that's why equals equals won't work the same way you want it to, because Java doesn't read minds. So you have to say, well, do you want to define 2 fractions to be equal in reduced form? Equivalent fractions are equal, are they not equal? Or just strictly the numerators and denominators are equal? Or another way of doing this even is to use the 2 decimal. We had a 2 decimal in here, right? That converted the fraction to a decimal value. You could define it as being 2 fractions as being equal if their decimal values are the same to, say, 3 decimal places or 5 decimal places. And because of all these different options, that's why you have to write your own and define your own equals method for your object, rather than Java interpreting it. Okay, hope that makes sense. Catch you next time.